Okay, in this video we're going to look at solving log equations. So if we've got an equation in the form 5 to the power of x equals 67, what we do, we take logs of both sides. Now my own preference would be to use the natural log. Some people would have a preference for log base 10. It doesn't matter, it's up to the person working out the question. So throughout my videos I'm going to use the natural log. So we've got ln of 5 to the power of x equals ln of 67. So we can use the laws of logs to bring x down. So x times ln 5 equals ln 67, and then we can divide them. Therefore x is ln 67 over ln 5. So we can use our calculator to work out the value of that. So we do ln of 67 over ln 5. So I get 2.61 corrected 3 significant figures. 2.61 to 3 significant figures. You'll get the same result if you use log base 10 as well. Here's a question for you to try. You can pause the video, and when you're done, I will go through my work solution. Okay, welcome back. So we do ln of 2 to the power of x equals ln of 67. And then we can say we've got x times ln 2 equals ln 67. So x would be ln 67 over ln 2, rounding our answer to 3 significant figures. So ln 67 divided by ln 2 will give me 6.07, correct to 3 significant figures. So in our next example, we've got 4 to the power of x plus 2 equals 51. So we do the same thing as before. We do the natural log both sides. So we do ln of 4 raised to the power of x plus 2 equals ln of 51. So bring the power down, x plus 2 multiplied by ln 4 equals ln 51. So we get to multiply both things by ln 4. So we get x times ln 4 plus 2 times ln 4 equals to ln 51. So we get x ln 4 plus ln 4 squared from the laws of logs equals ln 51. So x ln 4 plus ln of 16 equals ln of 51. So we can now minus them to say x ln 4 equals ln 51 minus ln 16. So x is ln 51 minus ln 16, all divided by ln 4, and we're going to round our result to 3 significant figures. Using our calculator now, so we get ln 51 minus ln 16 divided by ln 4. 0.836 to 3 significant figures. Here's a question for you to try. You can pause the video. When you're done, I will go through my work solution. Okay, welcome back. So we take ln of both sides. So we do ln of 3 to the power of x plus 1 equals ln of 23. So we do ln 3 times by x plus 1 by bringing the power down equals to ln 23. So we get x ln 3 plus ln 3 equals to ln 23. So x ln 3 equals ln 23 minus ln 3, and then we can just divide by ln 3. Therefore, x is ln 23 minus ln 3, all divided by ln 3, and we can work out our result on our calculator. So we just get ln of 23 minus ln of 3 divided by ln 3, 1.85. So that is 1.85 correct to 3 significant figures. So the next type of log equations is something in this form. So what we ought to do is say we need all of it looking the same. So it's 5 to the power of x, but it is 5 to the power of 2x. So I'm going to manipulate the indices by saying that 5 to the power of 2x is exactly the same as 5 to the power of x all squared. You should know that from the laws of indices. So I'm going to rewrite this as 5 to the power of x all squared, which is equivalent, minus 5 to the power of x, and it equals 6. I'm going to make it minus 6, so it equals 0. Now this looks very familiar. It looks like a quadratic equation. So I'm going to get my calculator and type in my coefficients. So I can go to menu, press alpha and minus, and we're going to solve a quadratic. So I'm going to choose polynomial, degree 2, and type in my coefficients. Well, the coefficient of x squared is 2. The coefficient of the x term is simply minus 1. And the constant term is minus 6. So I get x equals 2 and x equals minus 3 over 2. So don't forget, x in our case is 5 to the power of x. So that's equal to minus 3 over 2, or 5 to the power of x is equal to 2. So the exponential function is only positive for y values. So all the y values need to be positive. So this is invalid. This can't happen. So what we're going to solve is 5 to the power of x equals 2. So we can say 5 to the power of x equals 2, ln both sides. So we get, from the laws of logs, bring the power down. So therefore, x is ln 2 over ln 5. And we can use our calculator to work that out. Giving our answer correct to 3 significant figures as always. So ln 2 over ln 5, which is 0.431. Correct to 3 significant figures. Here's a question for you to try. You can pause the video. When you're done, I will go through my work solution. Okay, welcome back. So we can say, as before, that 3 to the power of 2x is the same as 3 to the power of x all squared. They're equivalent. So we can say 3 to the power of x squared minus 6 times 3 to the power of x plus 5 equals to 0. So we can solve that quadratic as before. So menu, alpha minus 2, 2, put the coefficients in. So the first case is 1. Then the coefficient will be minus 6 here. And the constant term is 5. So we get the first solution is 3 to the power of x equals 5, or 3 to the power of x equals 1. Well, 1's easy because we know 3 to the power of 0 is always 1. So our first solution would be x equals 0, because it's the power. Then here we do ln 3 to the power of x equals ln of 5. Bring the x down. X times ln 3 equals ln 5. And then we can say that x is ln 5 over ln 3. And then we can divide them. So we get ln 5 over ln 3. Three significant figures is 1.46. Correct. To three significant figures. Okay, in the next type of example, we've got 6 to the power 2x minus 1 equals 9 to the power x plus 3. So we take the natural log on both sides. Bring the power down. Now expand the brackets. So what we need to do now is say we can raise this to x ln 6 squared. And now what we can do is say minus ln 6 equals to x ln 9 plus ln 9 cubed. So now we could write this as x ln of 36 minus ln 6 equals x times ln 9. And we're just going to do 9 to the power 3 here. So we get 729. So what I want is both x terms to be on the same side. So I get x ln 36 minus x ln 9 equals to ln 6 plus ln 729. So I can factorize the x out to give me ln 36 minus ln 9 equals to ln of 6 times 7 to 9. So I can also simplify the laws of logs here. So that's ln of 36 over 9 equals to ln of 6 times 729, 4374. And then that will give me x ln 4 equals ln 4374, and then we can divide them. To give my final result. .05 to three significant figures. Here's a question for you to try. You can pause the video, and when you're done, I will go through my work solution. Okay, welcome back. So we do ln of both sides. So I get x plus 3 multiplied by ln 5 equal to x minus 2 times ln 3. So we get x ln 5 plus 3 ln 5 equals to x ln 3 minus 2 ln 3. So that gives me x ln 5 plus ln 5 raised to the power 3 equals x ln 3 minus ln 3 squared. So that gives me x ln 5 plus ln 125 equals x ln 3 minus ln 9. So bring all the x terms to one side, so I get x ln 5 minus x ln 3 equals to minus ln 125 minus ln 9. That will give me x ln 5 minus ln 3 minus ln 125 minus ln 9, and divide them. And we should get our result. Correct 3 significant figures. Which gives me minus 13.8.